Hello friends, this is a channel for electromagnetism and other electronic subjects like digital and analog, uh, where we try to introduce and solve questions on these subjects. I'll try to solve all the gate questions and explain some theoretical engineering service questions also. This subject, electromagnetism, is usually most cases is divided into 5 parts. One is this Maxwell's equation, and the next is plane waves, and transmission lines, waveguides, and antennas. For electronics and communication, all these 5 parts are there. And if you are from electrical or maybe instrumentation, only Maxwell's part is there. So what we will do is I'll just give some introduction and then I'll try to add some problems to it. Okay. I'll try to cover at least some past 10 to 15 years, if possible, 20 years question, all the gate questions. I'll start with electromagnetism's introduction, that is Maxwell's equation. We will not go very deep, I'll just give introduction, so which is like I presume that you have some basic information already. Even if not, it's still okay. If you cannot solve all the 100% of the problems, maybe 60-70% of the problems you should be able to solve without much of a prior knowledge with whatever I teach here. First is we'll start with how this part of this this Maxwell's equation part will go. The flow of the class will be like this. We'll start with electrostatics. Then we'll talk about magnetostatics. Then finally we'll talk about electromagnetism. Here, why do we have 3 different situations? For example, if the charges are at rest, usually, I mean, that is the state called electrostatics case. It is not electromagnetism case. It is not a magnetostatics case. Why? I'll explain what is magnetostatics. Magnetostatics means a charge is moving. Only when a charge is moving, magnetic field is generated, a north pole and a south pole. So that is a magnetostatics. Magnetostatic case means a magnetic field is there and that magnetic field is a steady magnetic field. It is not changing with respect to time. So steady magnetic field. That is magnetostatics case. Electrostatics means charges are at rest. Magnetostatics means the source of the magnetic field is definitely moving charge. But although the charge is moving, the magnetic field is steady. The charges are moving with constant velocity. You can think of it like that. A DC current, you can think. All these are magnetostatics case. Electromagnetism means it is a case where both electricity and magnetism is there. One becomes other. It continuously, electricity becomes magnetism, magnetism becomes electricity. So that is the case of electromagnetism case. So we should see the experiment. For example, if a problem is given, see this whole videos that we do is particularly for the exam preparation. So when a problem is given in an exam, whether it is GATE, engineering service, first observation is you should find out what is the case they are talking about. Is it electrostatics case, magnetostatics case, or electromagnetism? After that decision only, you will start approaching the problem. So that is the first step. So we are going to study electrostatics, magnetostatics, electromagnetism. So under electrostatics, what are the topics we will study? Under electrostatics, we will talk about, under electrostatics, how will the flow of the class will be. I'll introduce what is called force, electric force and electric field, and then something called electric potential, and then we will talk about capacitors, capacitance, things like that. The same way in magnetostatics case, we will talk about uh, magnetic field. There is magnetic flux density actually. There is something called magnetic field intensity. The same way here also there is something called electric flux density. D is electric flux density, E is electric field intensity. And then we will talk about, here we will not talk about inductance. Here we will talk about these two, and then there is some current. What is the current involved here? These are the things that we will talk there. Then when it comes to electromagnetism, electricity becoming magnetism, magnetism becoming electricity. Here we will try to relate equations between E and H, E and H or E and B. And then we will talk about inductance, self-inductance, mutual inductance, things like that. And here we talk about magnetic force. See, before talking into all these things, basic physics. What will you study in the basic physics? For example, 11th standard physics. 11th standard physics book will go like this. They will introduce certain things called basic parameters or physical quantities. We say velocity, acceleration, and then they will mix mass into it. When you mix mass into velocity, we call it momentum. When you mix mass into acceleration, we call it force. And then with these things, they will make some equation. We call it kinematics equation. Kinematics equation means equations without force. It's just basic velocity and acceleration. And then they will introduce momentum and force. So this is the basic thing. After this, they will introduce something called work done, potential energy, kinetic energy, all the same. These are all the same things. The unit is joules, some cases electron volts, some cases calories, so whatever it is. This is how this 11th standard book will go, and after this they will talk about gravity. Here we are only interested in electromagnetism. So what are the parameters we will use here? The parameters that we will use here is, we will be interested in force, we will be interested in work done, we will be interested in kinetic energy, and some cases we will be interested in the kinetic energy. Very rare, we are mostly interested in the potential energy, because obviously we are interested in most of the problems we will be interested in electrostatics. Statics means charges at rest, so potential energy, not much of kinetic energy. Very rarely one or two problems they will talk about kinetic energy. Majorly we are interested in work done or potential energy. Alright, we will not talk about momentum, all these things. These are all used in the particle theory. We are only interested in wave theory. Okay, I will introduce that also a little bit. See, the basic physics, the nowadays physics, has 4 pillars. First pillar is electromagnetism. There are 4 forces of nature, they say. So the first is electromagnetism. The second is gravity, strong nuclear force, weak nuclear force. So there are totally 4 forces. Basically, as an engineering student and college school student, you are expected to know these 2 forces: electrostatics, electromagnetism, and gravity, gravitational force. Here, this electromagnetism actually has a dual nature. They say dual nature means certain things are explained better by wave nature, and the certain things are better explained by particle nature. Particle theory. Simply speaking, they have developed 2 different theories: wave theory, particle theory. Wave theories are used to understand things like polarization, which we will study here, and interference, which we will not study as a part of this electromagnetism class. And then there is something called diffraction. So these last 2 things, diffraction and interference, we will not study. It's not of much of our interest in this electromagnetism. But for all these 3, they use wave theory. Particle theory means whenever you are interested in energy transfer, work function, and there is something called momentum transfer, how much momentum is transferred from one to other. Those times in such situations they use particle theory. We are only interested in wave theory. So the electromagnetism class here, that is this thing, in all these cases we use what is called wave theory. We do not much use particle theory. Here and there they have borrowed particle theory ideas, but mostly we are interested in only wave theory ideas. So the whole thing that is developed very long ago, the Maxwell's equation is all 1800 and 1890. I don't think during that time this particle theory came into effect, because this particle theory came after 1905, this photoelectric effect, that is the starting point. So whatever this Maxwell's equation, this is all made with idea of wave theory, wave equations. We will talk about it. So basically what we have done is, in this part of the video, I have just introduced this subject called electromagnetism. For ECE case, all these 5 topics are there: Maxwell's equation, plane waves, plane wave theory, they say transverse electromagnetic wave, TEM they say. And then there is something called transmission lines, that is for the circuit case. And then waveguides, means in which case TEM is not enough, we need T and TM. And then antennas. If you are only electrical and instrumentation, only Maxwell's equation. Under Maxwell's equation means it's a consolidated set of 4 to 5 equations which compiles all the electrostatics ideas and magnetostatic ideas and electromagnetism ideas. So 2 equations in each case. So this Maxwell's equation. And then we are interested in 2 particular components, capacitance and inductance. So at the end of the subject, you should have understood at least how to compute capacitance and inductance for various cases. And electric field, for example, they might give you some charge distribution, ring charge distribution, what is the electric field for this, or line charge distribution, what is the electric field for this, what is the plane charge distribution, for the plane charge distribution, what is the electric field at some single point in space. The same way here also, a loop current is there, what is the magnetic field at the center, or maybe a solenoid is there, what is the magnetic field at the center. Like that they have asked. So such questions you should be able to solve. Alright, thank you.